All right, we just got done doing a marginal cost example. Now let's talk about marginal revenue. Remember, marginal is the rate of change, or the derivative. But let's first talk about what revenue is. Well, if you remember, that total revenue is related to the price per unit and the amount demanded, right, or the amount sold. So we can figure out the revenue by figuring out the number of items, we call that Q, like the quantity, times the price, right? So for example, our revenue is going to depend on how many of those things we sell and for how much we sell them for. That's how much our revenue is, right? How much we bring in. We have a cost, though, that we might have to bring out to produce these things, but a revenue is how much we're bringing in. So it's Q times P. I need you to make sure you remember that. Anytime they ask me for revenue, I need Q times P, the quantity times the price. Okay, so here's example number 7. It says here the demand function, so that's P, in dollars for a certain product is given by this. So this is the price depending on the quantity. Between 0 and 50,000 is my Q. It asks us to find the marginal revenue. As soon as I see that word marginal revenue, I know that they're talking about the rate of change in my revenue or the derivative of my revenue. When Q is 10,000 units. So when we sell 10,000 units, what is going to happen with our revenue? How is our revenue going to change? Well, we know first that revenue is really Q times P, the quantity times the price, okay? So our Q, we want to keep it as a variable for right now because this revenue is going to change depending on how many we sell, right? So we're not actually plugging in Q yet. So let's find the marginal revenue first, and then let's plug in the $10,000 so we know what the marginal revenue is when we sell the 10,000, okay? So we have our Q in our formula, a certain quantity, times the price depending on the quantity. Remember, P up above was 50,000 minus Q divided by 25,000. I'm going to go ahead and simplify this a little bit because this is really my revenue equation. And eventually, I'm going to want to take the derivative of this. But let's simplify it first before we take the derivative. Let's make it look a little nicer and into a form that we know derivative rules for. I'm going to take this Q and I'm going to distribute it to everything in my numerator. That means I have a 50,000 Q minus a Q squared all over 25,000. Oops, I didn't mean to delete that. Right? I didn't distribute the Q to the top because my Q has a denominator of 1. And when we multiply fractions, we just multiply tops with tops and bottoms with bottoms, okay? All right. Now, what I can actually do, I know that I'm going to have to take the derivative. And I see a division problem, but I don't see a variable on the bottom. What I do see is just a number on the bottom. And I know that when there's a number on the bottom, there's really a coefficient that ends up being a fraction. Do you see the 1 over 25,000? So I can actually take that coefficient and bring it out to the front and really say that I have 1 over 25,000 times 50,000 Q minus Q squared. Now, why would I do that? Well, if you remember our rules for derivatives, if I just have a number in front, which I do, I should be able to just leave that number and then find the derivative of the rest of my stuff. And that stuff now looks a lot nicer than having that denominator, right? So I took the 1 over 25,000 and brought it out front as a coefficient so I can leave it and then just find the derivative of the rest of my stuff. So this reddish equation is my revenue, but I still need to find the marginal revenue, the derivative. Remember, I can leave that 1 over 25,000 alone and then just find the derivative of the rest of the stuff. So the derivative of 50,000 Q is just 50,000 and the derivative of Q squared is 2Q. So here's my marginal revenue, the rate at which my revenue is changing depending on how many things I sell. The question, remember, asks us to find the marginal revenue when we sell 10,000 units. So let's go ahead and find our marginal revenue when we sell 10,000 units by plugging in a 10,000 into our marginal revenue equation. When I plug in a 10,000, I use my calculator to simplify. I ended up with 1.2. Make sure that's the right answer. Make sure you know how to get that answer in your calculator, and so that we all have the same values. You should end up with 1.2. But let's talk about what that actually means, right? A sentence with 3 things so that we understand what this answer actually represents in context to the problem. So when is it happening? What is happening? And what is our answer with correct units? Here we go. So after we sell 10,000 units, right? When we go to produce the next amount or sell the next amount, The revenue, because that's what this is talking about, the revenue is increasing. I knew it was increasing because this was a positive. If it were a negative 1.2, then I know my revenue is going down, right? But now it is increasing by approximately $1.2. So can I really say $1.20 per unit? After we sell 10,000 units, my revenue is increasing by $1.20 per unit. So I'm getting $1.20 more per unit than I was just a second ago. That's pretty good, right? I want that revenue to be increasing because that means I'm getting more money. All right, why don't you try one of these? There was a lot going on there, so I want to make sure that you understand before we move on. I want you to try it number 1. Pause the video, follow through like we did in the last example, example number 7, and see if you can find me using this P function, the price or demand, the marginal revenue when we sell 5 units. All right, as soon as we hear that word marginal revenue, I'm thinking rate of change or derivative of my revenue. But before I do that, I know that revenue is really Q times P, quantity times price. We don't know how much we sell, and that quantity is going to change, right? And our price function, our demand function is the 16 minus 1.25 Q. So here's my Q times my P. This is my revenue equation. But it's not my marginal revenue yet until I find the derivative. But before I find the derivative, I've got to simplify to make this equation look like rules that I do know. I'm going to go ahead and distribute the Q through. That gives me Q times 16, 16Q, minus 125Q squared. Now, this is a revenue function that has 2 terms in it that I know how to find the derivative of using the rules that we know. So let's now find the marginal revenue, the derivative. The derivative of 16Q is 16, and the derivative of negative 1.25Q squared is negative 2.5Q. Remember, bringing that 2 forward and subtracting 1 from my exponent. So this equation is going to give us our marginal revenue, the rate at which our revenue changes depending on how many things I sell, right? So I can find the change in my revenue when I sell 5, when I sell 10, when I sell 13. I can figure out how my revenue is changing at any moment. The question asks us to find the revenue change, the marginal revenue, when we sell 5 of these items. That means we're going to take our derivative, our marginal revenue equation, and plug in a 5. I ended up getting 3.5, did you? So then did you make a sentence with the 3 things that we said we needed? When is this happening? What is happening? And what is your answer with correct units? Well, when is this happening? Well, as soon as I sell 5 units, my revenue is doing what? Well, it's increasing because of that positive 3.5, and it's increasing by approximately $3.5 per unit, or can I say $3.50 per unit. After I sell 5 units, my revenue is increasing by $3.50 per unit. I'm getting $3.50 more per unit than I was just a second ago. Again, that doesn't mean I'm only getting $3.50 per unit. I'm getting $3.50 more than I was a second ago. Okay? So make sure you use the right wording there so that it's accurate.